Once again, welcome back to our channel. We are continuing exercise 9.1, question number 9. The angle of elevation of the top of a building from the foot of a tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter height, find the height of the building. Okay, so it is very important question. Okay, see, we have a building and a tower, okay, on the ground. So we can draw a ground and a tower is placed, and a tower and the ground will make 90 degree, and also we have a building, and building and ground also make 90 degree. And the height of the tower, this is tower and this is given as 50 meter. Okay, see, we can draw like this because here the height of the building is what we need to find out. Whether it is a taller or smaller, that is not given. That is not mentioned in the question. But what is given? We have given the angle of elevation of this top of the tower from the bottom or the foot of the building is given as 60 degree. Okay, and from the foot of the tower to the top of the building, that is given as 30 degree. Okay, so this is the building, children. Okay, see, by looking the angle of elevation, you can say that which is taller. That is from the foot of the building to the top, and its angle of elevation is 60 degree. And from the foot of the tower to top of the building, that is 30 degree. Okay, see, suppose two students are standing in front of me. Okay, one boy is taller than the other. This one is smaller one. Okay, in order to look into his face, I have to raise my head little more higher than this smaller one. That means the taller student having the greater angle of elevation. So here that tower is taller than, definitely taller than this building, because its angle of elevation from the bottom of or the foot of the building is 60 degree. Okay, that is greater than that angle of elevation from the foot of the tower to top of the building. This is the way you can confirm which is taller. Okay, so since this angle of elevation from the foot of the building to the top of the tower is given as 60 degree, okay, and from the foot of the tower to top of the building is 30, so definitely this is smaller than the tower. That point is clear, children? Okay, so this is the angle between this line of sight and this horizontal level. So this is 30 degree. So between these two, the angle of elevation is 60 degree. Idea is clear, children? Okay, now we can name the points. Here this comes A, this is B, this is C and D. See, you can see two right triangles. Okay, so consider right triangle ABC, that is big right triangle ABC, and second one is BCD. You can see that this BC is common side, isn't it? Okay, but in the first right triangle ABC, that big right triangle, first means big right triangle, we have the what is given, that is height of the tower also given, and its corresponding angle, that is acute angle, that is angle of elevation also given. So we can apply, we can easily get this BC. Okay, that what we need, children? DC is the height of the building. That is what we need to find out. Okay, so I am considering first the big right triangle ABC. Okay, and I am taking, because I am taking here this AC has no role here, that is hypotenuse, that ratio you need not take. So I am taking here that tan, because we can equate with the BC, because BC is common. So opposite side with the adjacent side. So tan of 60 degree in the big right triangle. Okay, so tan of 60 degree equal to AB by BC. Okay, so AB is given as 50 and BC is not given. Okay, and tan 60, its value is √3. And from here, we can write this equation with respect to BC by taking this BC to here. So BC equal to 50 by √3. This is equation number 1. Okay, and from the second triangle, that is BCD. Okay, so second right triangle, in right triangle BCD. Okay, here the acute angle, that is angle of elevation from the foot of the tower to the top of the building, that is given as 30 degrees. So opposite side by this adjacent side, because here we need this DC. So the ratio should have this side, that means tan of 30 degree. So tan 30 degree 30 degree equal to, that is with respect to 30, that is DC divided by BC. Next we can substitute that value of tan 30 as 1 by root 3. Here that is 1 by root 3 equal to DC by BC. Okay, and I am going to express this equation with respect to BC, because as I told in the beginning, this BC is a common side. Okay, so I am going to express this equation with respect to BC by cross multiplication. So 1 into BC is equal to root 3 into DC. Okay, root 3 into DC. So let it be equation number 2. See, in equation 1 we have an expression in BC. Here equation 2 also in terms of BC, which means you can equate their RHS part. That means root 3 DC. Here the variable is in equation number 2. So I am keeping that in the LHS. That is from equation from 1 and 2. From 1 and 2. Root 3 DC equal to 50 by root 3. Okay, and we need this DC, that height of the building. So DC is equal to 50 by root 3, and this root 3 come to denominator. And 50 divided by root 3 into root 3 is 3. Okay, so 50 by 3 meters. So if you want, you can divide and we can express in mixed fraction. So 50 by 3, so 1 time, so 2, and in 26 and 8. Okay, so you can write this as 16, 2 by 3 meter. 16 is a quotient, 2 is the remainder, and 3 is a divisor. So this is a mixed fraction. So this is the height of the building. Here we have given the poles are equal heights. That means AB equal to ED. That is given. Okay, AB, since the poles are of equal heights, so ED. And we can consider these two right triangles. Okay, that means triangle ABC. Okay, and we can represent this is equal to So now we can solve the problem, that is we need to find out the height of the poles and also the distance of so we can solve the problem, children. We need to find out the height of the poles, that let it be h, since they are of equal heights. So we can represent both with h, and also distance of this point away from the poles. Okay, so this distance and also this distance, that is what we need to find out. Okay, so since this total distance is 80 meter, okay, so I am going to take this distance BC as x, and what will be the distance of CD, distance of this point from the foot of this building, that is CD. CD is equal to 80 minus x, because the total width of the road is 80 meter. So this distance CD will be 80 minus x. Okay, so we can consider these two right triangles and we can solve this problem easily. Okay, so since AB equal to ED, so now we can solve this, so we are going to solve this problem, children. That is, we have to find out the height of the poles, and since they are of equal heights, we can now we can solve the problem. That means we have to find out the height of the poles, and since both are of equal heights, we can represent that AB and ED with H. And also the distance of this point from this A is from this B and from D. That means we have to find out this distance BC and let it be x. Okay, and this distance CD. So what will be CD if I am marking this BC as X, and since the total width of the road is 80 meter, so CD will be 80 minus X. We have to subtract this X from the total width. That means 80 minus X is the width of the second point. Okay, that means from this point to the foot of the second pole. Okay, and we can consider these two triangles separately and we will get to the expression. Okay, so first I am going to consider triangle ABC, and we can apply this one because we need height and we need this distance, so opposite side by hypotenuse. Okay, so tan of 60 degree. Okay, so we can write, before that we can write all these details. That means given the poles are of equal height, that means AB equal to ED, and we have taken that as height as H. Okay, and since the total distance is 80 meter, okay, and BD equal to width of the road, BD equal to 80 meters. So BC, let BC is equal to X, then CD equal to 80 minus X. So consider right triangle ABC. We can take tan of acute angle 60 degree, that is AB by BC. That means H divided by X. Okay, and tan 60 is root 3 equal to H by X. Okay, and we can write this in terms of height. That means we need height and also X, and I am writing this in terms of H is equal to, okay, X or root 3X. Let it be equation number 1. The same way we will have another expression from taking this right triangle in terms of H, then we can equate. Okay, so we have to find out height also, so we need this equation. Okay, now we can consider the second triangle, that is EDC. Okay, so consider right triangle EDC. Tan of acute angle is 30 for this second triangle, that is 30 degree equal to its opposite side, that is ED divided by adjacent, that is CD. Okay, and we can substitute, that is tan 30 as 1 by root 3, and ED is height of the pole, and CD equal to 80 minus X. Okay, and from this we can express this equation in terms of H. Okay, so we can cross multiply, that means 80 minus X and this denominator root 3 equal to H. So this can be equation number 2. Point is clear, children? So we have now two equations with respect to H. So from equation 1 and 2, you can equate the RHS part, because we need H also. Then after getting that value of X, we can resubstitute in order to get the height of the tower, okay, or the pole. So I am going to equate their LHS part. LHS part of this is 80 minus X divided by root 3 can be equated to root 3x, because both equation 1 and 2 we have in H. Okay, so from 1 and 2, okay, we have root 3x equal to, here the RHS, another part of H is 80 minus x divided by root 3. So cross multiplication, this root 3 can be taken to this side. So root 3 into, here one more root 3, then x. So root 3 into root 3 become 3x, right? Okay, so this root 3 will join with this root 3 under cross multiplication. So root 3 into root 3 become 3, and this x is not in the square root. So this is equal to 80 minus x. Now we can solve for x, then minus x come to this side, it will become 4x. 3x plus x is equal to 80. That means 4x is equal to 80, or x is equal to 80 by 4, that is 20. That means this distance is equal to 20. That is what we have taken as x. That is BC is equal to x. That is the distance of this point from this pole. Okay, that is equal to x, and the total distance is 80. So 80 minus x, that is 60. That is CD equal to 80 minus 20. That is equal to 60. So altogether you will have here 60 plus 20 become 80. So that is the one part. And another part, in order to get the height of the poles, we have two equations. Either you can substitute for here the value of x, okay, and or here. Since this equation is easy, I am going to substitute for x in equation 1. Okay. So from 1 h is equal to height of the pole root 3 into here what is x children? 20. So 20 root 3. Okay, so 20 root 3 is the height of the pole. Okay, and here the distance is 20 meter and here comes 60 meter. This is very, very important question. Now the 11th question. A TV tower stands vertically on a bank of a canal. From a point on the other bank, directly opposite to the tower, the angle of elevation of the top of the tower is 60 degree. From another point, 20 meter from this point, from the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degree. Find the height of the tower and the width of the canal. See children, even if this question is little bit lengthy, you read the question carefully and understand its meaning, and you can easily draw the figure, and hence you will get the correct solution also. Okay, so we can draw the figure. We have a canal and we have a TV tower stands on one bank of this canal and just opposite to the other bank. Okay, this canal, okay, this side of the canal, we have to mark the angle of elevation from a point just opposite to the other side of the canal. Okay, the angle of elevation of the top of the tower is 60 degree. So suppose this is the canal. Okay, this is the canal, and from this point opposite to this TV tower, the angle of elevation to the top of the tower, so this is the angle of elevation, and that is given as 60 degree. 60 degree. Okay. From another point 20 meter from this point means this is the point where we have marked the angle of elevation to the top of the tower, that is 60 degree, and from this point, okay, on the line joining this point to the foot of the tower, this is the foot of the tower, that means we have to extend this line and we have to mark a point which is 20 meter away from this point. Okay, this is that point, and the angle of elevation from this point to the top of the tower, that is given. See children, the angle of elevation of the top of the tower is 30 degree. Okay, so from this point to the top of the tower is 30 degree. And what is asked? The height of the tower and the width of the canal. Okay, so that means this is the width of the canal. So, and we can mark first A, B, C, D. So, width of the canal is BC and height of the tower is AB. Okay, see, from the figure it is very clear. That means here this tower and the ground, that canal will make 90 degree. So, see, as we close to the tower, the angle get increased. As we move away from this foot of the tower, that angle get decreased. Okay, see, this is 30 degree only. So, when we are approaching to the tower, that angle get increased. That point is clear children? Okay. So, from the figure, the width of the canal is BC and the height of the tower is AB. So, we can write first from the figure, width of the canal equal to BC, height of the tower equal to AB. This is what we need, and for that we can consider these two triangles. See children, triangle ABC and the big triangle ABD, which side is common? AB is common. Okay, so first of all we can consider this big right triangle, that is ABD. Okay, consider this distance also given. Okay, DC is given as 20 meter. Okay, so consider right triangle, big one we are considering first, that is ABD. Okay, see children, here we need only this side, this height, and this width of the canal. Okay, width of the canal is BC, and we don't want this hypotenuse with respect to this 90 degree. So we can select tan, this case also. So tan 30 degree, acute angle for this big one is tan 30 degree equal to AB by the big side, that is BD. And we can substitute this tan 30 as 1 by root 3, and we can take the height as h. Okay, that is height of the tower as h divided by BD. BD we can split. Okay, such a way that DC plus BC. DC plus BC. Okay, so let it be, and DC we have given as 20. So 1 by root 3 equal to h divided by DC, this point from this width from this point to this point is 20, that is given, and BC. Okay, so I am going to write this in terms of h. Okay, so h equal to, for that I am cross multiplying this denominator with 1. So 20 plus BC and this denominator root 3. Let it be equation number 1. Okay, and for forming the second equation we can consider this small right triangle. Okay, that means now consider right triangle ABC, this one. Okay, and we can take its tan of 60 degree, its acute angle is 60 degree, that is AB, that is h divided by BC, or root 3, that is value of tan 60 is root 3 equal to h by BC, and we can get to this equation with respect to h. We have already one equation in terms of h. Okay, so we will get h is equal to root 3 BC by cross multiplication. This is equation number 2. Okay, from equation 1 and 2 children, since both are in terms of h, you can equate the other side, that is 20 plus, from 1 and 2, 20 plus BC by root 3. This is the RHS part of the first equation. And here this we have also one equation in terms of h, so you can equate this with that equation, that part, root 3 BC. Okay, see children, here we have only one variable, that is BC. So you can easily solve for BC from this equation. For that I am taking this root 3 to RHS, so multiplication. Okay, so 20 plus BC. Okay, so root 3 into root 3 become 3BC, right? Okay, so I am taking BC to that side. So 20 equal to minus BC. Okay, 3BC minus BC, that is equal to 2BC, and BC equal to 20 by 2. This 2 will come to denominator, or this is equal to 10 meter. That means here the width of the canal, we have seen that 10 meter. And what else we have to find out? Width of the canal and the height of the tower. And we have two equations for height. This equation number 1 and equation number 2. I think this would be better because it's simple equation. So height will be, see here from 2, h is equal to, we have root 3 BC. So we can substitute for root 3 BC as 10, or 10 root 3 meter. This is the height of the tower. Okay.